Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides a review of the concept of critical values and how to find them using StatCrunch. Let's get started. So remember that we were using z-scores in previous mini lectures called critical values. And these critical values were used to distinguish sample statistics that were likely to occur from those that were unlikely to occur. So the values that are found in the tails of the distribution are those that are unlikely to occur, and the values that are found in the center region of the distribution are those that are likely to occur. The z-score separating each tail region from the bulk of the distribution is commonly called z alpha over 2. When you see z alpha over 2, then what you're really looking at is saying that our critical region, which is bounded by the critical values, is going to be in two parts, hence the half. So half of alpha is on the left, half of alpha is on the right. Now, of course, if you see simply z sub alpha without the over 2 part, then that's talking about a critical value for just one tail of the distribution, and usually it's talking about the right tail of your distribution. So z alpha over 2 in this particular example here are z-scores of plus and minus 1.645. Because you've got half of alpha on the left and half of alpha on the right, you have two boundary regions for your tails. So there's one boundary here and there's one boundary here. And these boundaries, the z-scores that correspond with those boundaries, are your critical values. So whenever you have a two-tailed critical region, you're going to have two critical values. Z alpha over 2 is a critical value because it separates z-scores from sample proportions that are likely to occur from those that are unlikely to occur. Again, it's bounding off those tailed regions of the distribution. So here we have a table where we've got the most commonly selected confidence levels, significance levels, and the corresponding critical value z-scores for each of those levels. So if we have a 90% confidence level, that means we have a significance level, alpha, of 10%, and the corresponding critical value z-score is 1.645. You can see the other values listed there in the table. And these values, I could tell you that you want to memorize them because they're extremely common when you're working problems. However, I tend to find that most students tend to memorize these values by default, simply because they see them so often when solving problems that constant repetition serves to help them memorize the values. Let's look at some examples where we're looking at finding one-tailed critical values. So find the critical value z sub alpha that corresponds to the given confidence level. So what that means is we're looking for the area in the tail to the right that corresponds with the given confidence level. Remember, confidence level is 1 minus alpha. So here in this first example, if our confidence level is 75%, that means our alpha or significance level is 25%. So what is the z-score that separates the right tail from the rest of the distribution with that right tail area equal to 25%? Well, to do that, we can go into StatCrunch, and notice we're using the default values that give us the standard normal distribution. And we stick in the 75% because the 75% is the area to the left. The 25% is the area to the right. But that boundary is going to be the same either way. Here we've got 0.67. That's our critical value z-score in that particular instance. Remember, your confidence level is the area under the curve outside the critical tailed region. So the area there on the curve that's shaded in red is what goes into the field on the right side of that equal sign. That's an area or probability. This means that 0.67 is our critical value z-score, or z sub 0.25. Now let's look at another example, 84%. Go ahead and stop the video here, get into StatCrunch, see if you can solve this one yourself, and then come back and we'll see how well you did. Okay, let's see how well you did with this. So 84% confidence level means the area on the left side of the distribution is 84%. So I'm going to put that 84% there in my probability field. When I hit compute, my z-score comes out 0.99. So that is the critical value z sub alpha that corresponds with that given confidence level. Let's look at some two-tailed critical values. So we're asked to find the critical value z sub alpha over 2. We know this is a two-tailed critical value because we have alpha over 2 and not just alpha. That means alpha is split in half amongst the two tails, one on the left and one on the right. So if our confidence level is 75%, what would our critical value z-scores be? Well, again, in the normal calculator, this time we're going to select the between option up at top, and that way we can have two values that come out. We put the area in between those critical values here in our probability or area field, and that's 75%. And then we hit compute, and out comes our critical value z-scores. So both of these values are the critical values. Because we're looking at a two-tailed critical value, we have two critical values. Remember, your confidence level is the area under the curve outside the critical tailed regions. It's the area in the middle of the distribution. Now, let's do another example, looking at 84% confidence level. So go ahead, pause the video, get into StatCrunch, and see if you can work this yourself. Then come back and we'll see how well you did. Okay, see how well you did with this. So there in StatCrunch in your normal calculator, you should have something that looks like this. Notice we've got 84% there in the field on the right. That's the probability or the area of the curve that's in between the critical value that's bounding off the tailed regions of your distribution. And so we have two critical values, plus or minus 1.41. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.